Today we are doing lesson 14, solving systems of linear equations without graphing. To start this off, this is workbook page 203. So on workbook page, you're asked to consider this graph that represents a system of equations. In part A, we're being asked to estimate the coordinates of intersection of the point of the lines. So take a moment, take a look at this point of intersection. What do you think this point is? Where are these graphs meeting? And then just like we were doing before, part B says to determine whether your estimate from part A is a system to the solution. So pause, take a moment, see if you can think about those two things. All right, so I'm not sure what you guys have for a point. To me, it looks like maybe our x value is maybe 1.5. I'm just going to put 1.5, makes it easier to write. And our y value is definitely 3. You know that for sure. So now letter B is asking us to determine whether this estimate from part A is actually a solution to the system. So that means we're going to remember to put each point in to the equation and solve. So our two equations are y equals 3 and our second equation is y equals 7x minus 8. Oh, that's a 7. All right, this is a 3 over here. Ugly 3, but it's a 3. All right, let me actually fix that. That's bad. I didn't realize how bad that was. Back to the pencil. Y equals 3. So if I'm plugging these points in, instead of writing y into this equation, I am going to write 3. So does 3 equal 3? Yes. So we could definitely say that, yes, this point is a solution for this first equation. Now let's look at our other equation, y equals 7x minus 8. And again, instead of writing y, I'm going to write 3 equals 7. Instead of writing x, I'm going to write times 1.5 minus 8. So now we're going to go ahead and do this math. So 7.5 or excuse me, so 1.5 or 1.5 times 7 is equal to 10.5. And then we have minus 8. Does that equal 3? Well, 10.5 minus 8 is 2.5. 2.5 does not equal 3. So for this second equation, 1.5, 3 is not a solution to this second equation. So from here, what do we do is really the question. We could sit here all day and guess points, right? Maybe this is 1.4, maybe it's 1.3, maybe it's 1.43. We don't really know exactly what it is. So that's why today we are going to go over a different method for solving a system of linear equations besides just graphing. So if you go ahead and turn your workbook to page 205, again, this is the system from our problem 1. We had our two equations, y equals 7x minus 8 and y equals 3. So let's take a look at how to solve this more precisely than just using graphing. So letter A is asking us to write an equation in one variable to represent the system of equations. So what that means is in our top equation, we have two variables, right? We have a y and an x. Our second equation is already one variable, but we really want to combine these two equations so that we only have one variable. Since one of our equations, actually both of them, since our equations are already written in slope-intercept form, they are literally telling us what y equals, and we can substitute one equation in for the other. In this case, it is going to be a lot easier to put this equation into the top one. So this second equation is telling me y equals 3. So if y is 3, in my first equation, instead of writing y, I can literally write 3 and rewrite my equation. So writing an equation in one variable would give me 3, because I don't have y anymore, equals 7x minus 8. And now we can use this equation to actually solve. I'm going to see if texting is easier because using the text box is easier. So we're starting with 3 equals 7x minus 8. We want to get our y alone. So the first thing that we're going to do is to add 8 to both sides. Leaves us with 11 equals 7x. Remember, our goal is to get y alone, or excuse me, x alone. So now we're going to divide both sides by 7. And let's just leave that as a fraction. Let's just leave that as x equals 11 over 7. As you'll see that this is not a very friendly fraction if you were to divide that out. So we'll just leave it as 11/7. So what this is telling us is that the solution to the system of linear equations is, remember, 11/7 is our x. Our solution is a point where these two lines are intersecting. So our x value is 11 over 7. That is literally what we got when we did the work over here, right? We literally got x equals 11 over 7. And our y value just simply comes from above, right? Up here, we're being told y equals 3. So our solution is actually this point, 0.11/7 over 3. Not very friendly to graph. That would have been very difficult to see on the graph. But now we know through substitution that this is a solution to the system of linear equations. So I'm going to have you guys practice problems 4 and 5 in case someone's making me too quiet. So do these two problems on your own. Pause the video. All right, now let's look at a couple problems that look a little bit different. Here, I'm not sure what workbook page this is. This is page 206. Yeah, page 206. So on page 206, we now have some problems that look a little bit different, right? Now our equations are not written as y equals something. So there's a couple different ways to go about solving this. One way is to still, of course, use substitution, but this time we can still write it in one variable. And here on this first equation, we are being told, these both start with 3x. So in this one, we're being told 3x equals 3y minus 6. This one, 3x equals 2y. If 3x and 2y are the same thing, I can just put this in for this. And I know it might sound a little crazy, but that is what this means. These equal signs are literally telling us these things are equal. So instead, I could write this as 2y equals 3y minus 6. So from here, I can end up solving for y. So you are going to need definitely your little um, papers to help you solve these. Now we do have equations on both, or excuse me, variables on both sides of the equal sign. We want y alone, but I'm first going to move all of my variables to one side, and it doesn't matter which side. 2y minus 3y is going to leave me with negative 1y, or just negative y, equals negative 6. One more step. I don't have y alone yet, so I do need to divide both sides by negative 1 to get me to y equals 6. So remember, a solution to a system of linear equations is a point. So far we have only determined the y coordinate. As of right now, we don't know what the x coordinate is. So we do have to now pick one of these equations and substitute in the y into one of these equations. I'm going to choose the bottom one, just a little bit easier. So I am going to choose this bottom equation. I'm going to type it out. Type it out. I don't want it here, actually. I want it here, I guess. All right, 3x equals 2. Instead of writing y equals 6. So 2 times 6. And now let's solve this. So 2 times 6 is 12. 12 equals 3x. I want x alone. Divide by 3. Divide by 3. X equals 4. So now I can say the solution. Ah, I'm not going to be able to see it. I'll move it up here. Hold on. Wait, I thought I could. Hold on. There we go. Thought I could move it. So now we can say, moving on, the solution is the point 4, 6, because x equals 4 and y equals 6. So just trying these couple out, they are a little bit different. So you can try out this problem. If it were me, I would look for things that I have in common. So here I have y plus 2 and y plus 2. So I could literally rewrite this, and instead of writing y plus 2 into the top equation, I could write 4x and end up getting x alone first. All right, try problem 7 out.